Let's look at section 3.1. We want to know, is the ordered pair a solution to the following equation? 3, 5 is our ordered pair. The first coordinate is known as the x-coordinate, and the second coordinate is the y-coordinate. In order to see if this is a solution, I need to substitute that x with a 3, and I am going to replace the 5 into that y. When we do the substitution, don't forget you need parentheses around each of those values. And we can evaluate both sides now. 5 times 3 is 15. 2 times 5 is 10. And that is equal to 25. The left side, 25 is equal to 25. So in this case, we have 3, 5 is a solution. So yes, 3, 5 is a solution to the question. Example 2. The ordered pair we're going to test is x, y, or 0, 6. We are going to replace the x with a 0, and the y is replaced with a 6. Let's do the substitution. 9 times 0 minus 4 times 6 is equal to negative 24. 9 times 0 is 0. Negative 4 times 6 is negative 24. And that's equal to negative 24. So clearly, negative 24 is equal to negative 24. And again, we have, yes, the ordered pair, 0, 6, is a solution to the equation. In example 3, let's have you try the problem on your own. Let's do question 3 together. Again, I like to label x and y on the top so I don't make a mistake in my substitution. The x is replaced with a 7 and the negative 8 goes in place of the y. Doing the substitution, we have negative 2 times 7 plus 3 times negative 8, and let's check if that's equal to 38. Negative 2 times 7 is negative 14. 3 times negative 8 is negative 24, and that is equal to 38. On the left, we have negative 38 equals 38 on the right. This is clearly not true. Negative 38 is not equal to 38, so no. 7, negative 8 is not a solution to our equation. It is not a solution. Let's draw our Cartesian plane. The horizontal axis is known as the x-axis, and the vertical axis is known as the y-axis. The first point is 5, 2. I like to label it as x and y, so we know how to graph these points. The 5 is positive, so that means we're going to go to the right 5. 1, 2, 3, 4, 5. The 2 is positive, and that means we're going to go up 2 from that point. So we have 5 to the right, up 2, and that's our first point, 5, 2. For our second point, it's 3, 4. That means I start from the center again, the origin, and go to the right 3 spaces, 1, 2, 3. And since that's a positive 4, we're going to go up 4. 1, 2, 3, 4. And so this is the point 3, 4. For the third ordered pair, it's 2, negative 6. That means we go to the right. Since the first number is positive, we go to the right. And the second number is negative, so that means I need to go down 6 spaces. 1, 2, 3, 4, 5, 6. And so this is the point 2, negative 6. For the last point, It's a negative 4, so start in the middle, the origin, and go left 4 spaces. 1, 2, 3, 4. And since the second number is positive, we're going to go up 1 unit, and this is the point, negative 4, comma 1. Again, just to review, the first number is going to be a positive number. That means you're going to go to the right. If it's a negative number, that means you're going to go to the left. Always start at the origin or the intersection between the x and y axis. For the second number, it's going to tell us to go up if it's a positive number, or down if it's a negative number. Now I want you to try the next example. Let's graph these points on the Cartesian plane. Draw yourself an x-axis and a y-axis and try this one on your own. Let's do it together now. Again, I like to label these x and y so I know exactly what they mean. For the first point, it's negative 3 comma negative 5. Go to the left 3. 1, 2, 3. And go down 5. 1, 2, 3, 4, 5. That's our first point. Let's label it as negative 3 comma negative 5. For the second point, negative 5 comma 3. Left 5. 1, 2, 3, 4, 5. And up 3. 1, 2, 3. It is also really helpful if you use some graph paper. So you don't have to sketch these by hand, you can use graph paper. For the third point, 4 comma 3, or 4 comma negative 3 that is, so we'll go to the right 4. 1, 2, 3, 4, and down 3 spaces. 1, 2, 3. And this is our third point, 4 comma negative 3. For the last point, we have negative 2 comma negative 1. That's 1, 2 to the left, and down 1. This is negative 2 comma 1. So we're pretty confident now that we can graph all of these points on the Cartesian plane. Again, remember the horizontal axis is known as the x-axis, the vertical axis is known as the y-axis, and the point where they meet, the x and y-axis meet, is known as the origin. This point is known as the origin. And we have quadrants. This is known as the first quadrant, this corner here of our Cartesian plane. The second quadrant is this corner. The third quadrant is here on the bottom left. And finally, the fourth quadrant is this quadrant here on the bottom right. These are known as quadrants because they split the Cartesian plane into quarters. Example 6, let's complete this table. The equation 5x minus 3y equals negative 12 is given, and we have certain values of x that we need to plug in. The first one is using a negative 3. I am going to replace the x with a negative 3, and we're going to solve for y. 5 times negative 3 is negative 15. And now I could solve for y by adding 15 to both sides. Negative 3y is equal to a positive 3. Negative 12 plus 15 is a positive 3. Let's divide both sides by negative 3, and we can solve for y. This gives me y is equal to a negative 1. That means our first ordered pair is negative 3 comma negative 1. That's a solution to the equation. And for the other 2 points, we just do it again. Let's give that a try. We're going to substitute a 0 for the x. 5 times 0 minus 3y is equal to negative 12. 5 times 0 cancels out. Negative 3y is equal to negative 12. Let's divide both sides by negative 3. And now y is equal to negative 12 divided by negative 3. That's a positive 4. This means that 0, 4 is also a solution to the equation. For the last part, we'll replace x with a 3. 5 times 3 minus 3y is equal to negative 12. 5 times 3, that's 15, minus 3y equals negative 12. Let's subtract 15 to both sides. Negative 3y is now equal to negative 12 minus 15 is negative 27. We can divide both sides by negative 3. And this gives me y equals a positive 9. Y equals a positive 9. That completes the table. And so the nice thing is we can actually plot these points on the Cartesian plane. I want you to try that, and you will realize that these points lie on the same line. So if you plot negative 3 comma negative 1, 0 comma 4, and 3 comma 9 on the Cartesian plane, you will realize that these points lie on the same line. Give it a try and see if that's true. In example 7, it's your time to try it out. Plug in the values negative 3, 0, and 6 into the equation and solve for the y coordinates. Let's try this one now. For the first substitution, let's plug in x equals negative 3. So y equals 2/3 times negative 3 minus 2. We can reduce this. And so we have 2 times negative 1 on the top. That's equivalent to negative 2 minus 2. So y equals negative 4. That's my first ordered pair, negative 3 comma negative 4. We'll do it again. Let's substitute this time with a 0. Y equals 2/3 times 0 minus 2. That's nice because the 0 cancels out the 2/3. And so y equals negative 2 is our solution there. One more time, let's substitute x equals 6. We have y equals 2/3 times 6 minus 2. And so I can simplify. The 3 reduces with the 6. And this becomes a 1 down here. And the 6 reduces to a 2. 2 times 2 is 4. So we have 4 minus 2. So y is equal to a positive 2. So that's our third point. Again, if you were to graph this, you'll realize they actually lie on the same line. So let me do that for you here. We'll start with negative 3 comma negative 4. 1, 2, 3. Down 4. 1, 2, 3, 4. Then the point 0 comma negative 2, which is right here. And the last point 6 comma 2. 1, 2, 3, 4, 5, 6, and up to 1, 2. This is the point 6 comma 2. And if you look carefully and connect all of these points, they actually form a straight line. So this 3 points are actually collinear. They're on the same line.